Yes, you can use React.lazy without React Suspense. However, I would recommend against it. And in this video, I'm going to explain why that is. So here's a little demo app I've created. And what it's going to do is when I click on this button, it's going to set this React state is showing lazy, which is a Boolean, to be true. So on click, it's going to set that to true. And when that value is set to true, it's going to render out this component here called lazy content. Now, right now, lazy content is just the default export from this other file over here I have called content. So you can see it's got default. I'm exporting a component by default, and it's just a div with some Tailwind classes and some content inside it saying, I am some lazy loaded content. So if we come over here and we click on our button, you'll see that that component just swapped out immediately. So there's nothing lazy going on here. This is just a normal import inside our component here. And this code is going to be bundled together with our component. And so it's just going to swap immediately. So let's, when I click that button, so let's change it so that now it's going to be a actual lazy component. So I'm importing lazy from React, and I'm wrapping this function here, which is known as a dynamic import. So this import statement won't be, the code for this component won't be included generally in the bundle that this file is in. It will be in a separate bundle. And what happens is when the runtime kind of comes across this dynamic import, it's going to go out and get this code, bring it in, and then when it's ready, React will render it out. So let's take a look at, other than that, the code itself is unchanged. It's still just rendering out that component. So we come back here. You can see it sort of went purple, and then green very quickly. And that's because this dynamic import is happening very fast. Now, what I could do is try and go in and slow down the network speed, but I'm just going to cheat a little bit here. And I'm just going to wrap this dynamic import inside a delay function that I made. And all that's going to do is at first it's just going to wait for that dynamic import to finish, and then it's just going to add another 2 seconds on top of that. So we can slow it down, right? So what React's doing is, what a dynamic import is doing, with your lazy component, is that when it's rendered into the tree, React is throwing a promise for that code to be ready. And once that promise resolves, then React's going to re-render. So I'm just delaying the resolution of this promise. So if we come back over here now and we click Add Lazy Content, you can see I'm getting this loading purple box, and then the green is coming in with this I am some lazy loaded content. So that purple box is my fallback UI. So when this promise is sort of in a pending state, it's going to render out this fallback here. Right. And this is how we kind of want this app to work, right? So I've got a suspense boundary here. And what's happening is when that lazy component is rendered and it throws that promise, React is going to walk up the tree until it finds a suspense boundary, and then it's going to render the fallback UI until that promise resolves, and then it's going to render again with the new component. Right. Cool. So now let's take a look at what happens when we have a suspense boundary around our entire application, right? So instead of just around this part. So I'm going to click the button, and you can see that our whole app kind of got junked, and then it got re-rendered with the new content. And that makes sense, right? So what happens is the promise is thrown for the dynamic import for the lazy component, and it's just going to walk up the tree until it found a suspense boundary, which in this case was quite high in the tree. And then it's going to render that fallback UI until the promise resolves, and then it's going to re-render with the new component ready to go. Okay, so then the question becomes, well, what happens if we don't have any suspense boundary at all, right? Well, let's see what happens. So I'm going to click the button now. Nothing changed. And then we see the button, this content here, swap out. So I'm just going to do that again. So I click the button, nothing happens, and then this button, and then this content gets swapped. So what it looks like is happening is actually something similar to this, right? Where we click the button, and it is as if there is a suspense boundary kind of around this section, right? And then but there's no fallback UI. It's using the old UI as the fallback. And then when the promise resolves, it it shows this new component, right? I actually thought it would have behaved like this, right? Where you have a suspense boundary at the root and you click this and it kind of does this, except instead of maybe no fallback UI, it just says nothing. It's just like a white screen. And then when the promise resolves, it renders it. But actually it behaves closer to this one. It's a little bit different in that it sort of holds on to the old UI, but it's quite similar to this. Okay. So yeah, let's keep going. So I've looked at what happens when you're changing like a state value to conditionally render in this component. Well, let's take a look at now what happens when instead I'm just going to set that value to be the state value to control whether the lazy component is being rendered. I'm just going to set it to true straight away. I'm not going to wait for a click. So in the initial render of our app, it's going to have a lazy component. So let's see what happens when I've got a local suspense boundary, right? You see it immediately renders that fallback UI. And then when it's ready, it comes in with a new component. Great. Again, if we have a suspense boundary kind of around our app, you'll see that it renders that fallback UI. And then when that's ready, when the promise is resolved, you see the whole UI be rendered. Now, let's have a look at what happens when there's no suspense boundary. It's just white, right? And then the app is kind of ready. So it's really interesting. So it means if you're not using a suspense boundary and you conditionally load in or conditionally like show a lazy component during runtime, it will behave closer to this one where there's a suspense boundary around the lazy loaded content. And if it's an initial render, it'll actually behave closer to this one where you've got the suspense boundary around the outside, except in our case, there's no like fallback UI. So it'll just be white. And then when the promise is resolved, it'll just render. Okay, so back to the question, should you use a suspense boundary if you're using lazy? And I think the answer is you generally should. And the reason is because if you don't add one, let's say you are in this case here and you haven't added a suspense boundary, right? Things might be working how you expect when you're doing conditional rendering of lazy components. It's like, yeah, like this is working how I kind of expected it to work. But then at some point, either yourself or someone comes in later and adds a suspense boundary higher in the tree. And all of a sudden your experience changed in a way you didn't expect, right? So that would be my first reason to say, please use suspense when using lazy. It's that you don't want to be surprised by this change of behavior when someone adds in a suspense boundary, right? Either yourself or someone later adds in a suspense boundary. It's going to change how your experience is behaving. You kind of don't want that. I think it'd be better to not be surprised by that at some later point. Also, the fact that it behaves differently in a conditional render setting, right? Come back here, right? This is when it's being conditionally rendered after loading, right? It behaves one way and it behaves a different way when you're doing an initial render. That also pushes me away from leaning on this behavior because it's just very hard to reason about what's actually going to happen in your application. Like if it's being conditionally used, it'll behave one way. If it's being not conditionally used, it'll behave another way. Like just save yourself the pain and just always use a suspense boundary where it makes sense. And that way it'll predictably kind of behave in all of these different scenarios. And most importantly, using suspense with React Lazy makes it easy to give very clear experiences to users. So here's the example application without the suspense boundary. And when I add the component, the lazy component into the React tree, the user's not given any cue about kind of what's happening. All of a sudden, the lazy component just sort of pops in at some point. Whereas one of the main value propositions of using suspense is that you can very explicitly call out, these loading states for particular areas of your application and allow users kind of more signal, more cue about what's happening. So when I click here, I can show a loading state and then I can swap it out for the main one, which is I think a much clearer experience than just having sort of nothing happening and then all of a sudden a change occurs. While I was making this video, I was inspired to put together a proposal for the React team where I give an idea on how potentially we could align this suspense behavior so that, if you're not using a suspense boundary explicitly, it would sort of behave sort of as if there were a suspense boundary, just to make things more obvious and consistent for makers. But anyway, you're welcome to look into that if you're interested. I hope you found this interesting and helpful, and I'll catch you in the next one. All right, bye.